just one of the organizers of this meetup along with Noah. And yeah, we're excited to have you guys here. So quick on the agenda. We'll just these basic introductions, but just like Noah said, we have three incredible speakers, all of them very experienced developers, Alex, Jesus, and Kevin. So we're going to get started with Alex's presentation first. Of course, if you guys can use that chat functionality throughout the whole thing, you also can totally unmute yourselves at any time. Just try to be respectful of the speaker and make sure that they're, getting their entire presentation out. But yeah, I'll let Noah introduce Alex because they are buds, but yeah, we'll go from there.
Awesome. Thank you, Ellie. Yeah, everybody. So I am extremely excited. Alex had to step away last month from our meetup. I'm glad to see that you're doing well, Alex, and back with us again. So for those of you who don't know, Alex Jewell, he is a dev with over 10 years of experience, and he's currently a socially driven lead software engineer in the crypto custody space at PolySign for standard custody. For the past 8 years, Alex has been a blockchain and decentralization consultant and activist, capital A. In his free time, he's an artisan food porn director and social media marketing expert at Best Food Alex on Instagram. Check him out. He likes hanging out with his 2 floofy dogs and incredible wife, Jordan, and has an acute interest in arguing about politics with your uncle on Facebook, while talking about macroeconomics with your aunt. He's currently taking invitations to your family's next barbecue. He's a progressive, technocratic ghostwriter for political organizations, global economic forums, and watchdog groups dealing with the 4th Industrial Revolution, futurism, and decentralization. And like Heather said, a personal friend and mentor of mine. So Alex, please take it away.
Hey, thanks. Thanks, Noah. It's good to see you. And Noah's got an awesome dog that is friends with ours. So.
Yes, I can concur. They are some of the floofiest dogs.
Awesome. So before I dive in here, let me share my screen and let me present. Oh, it always gets in the way of where the buttons are. All right. Everybody can see?
Yes.
Awesome. So really, a lot of this is going to be a bit conceptual. Going to note here that a lot of the JavaScript itself, in terms of how you connect in the Web3 world, is relatively simple, and some of the complexity is understanding the concepts. I'm going to do a couple demos near the end that look at a Web3 app. But the idea is that you're essentially dealing with blockchain objects on the window, and you have Chrome extensions and some libraries that help in that regard. But I will go over the concepts there, and feel free to ask any questions. This is what the agenda is going to look like. I'm going to introduce myself, going to add a disclaimer here, that I'm going to tackle a couple of concepts. What is Web3? What is Ethereum? Especially around, why smart contracts in particular are interesting. Look at the stack itself. Look at the stack itself, and then do a couple of demos that will show. I'll dig into the code, show you the code side as well as the app side, so you kind of see how it all connects. And then we'll talk about the future a bit. Because Noah already gave a great introduction, this is essentially what's here. So I'm Alex, and Noah tackled this very well with the wordy description of myself from LinkedIn. All right, this is really important, this disclaimer. This is not about money. This has nothing to do with investment. I'm not telling you at all to buy anything. I'm not telling you to invest in anything. Really what I want to look at here, as huge brands and as this idea of Web3, obscure and abstract as it is, becomes more and more important in terms of how those brands interact with people, how creators interact in this evolving space. I want to show you how JavaScript can be a part of that conversation. And so especially this coming off of this week where you've had huge exchanges that have crumbled, that were Ponzi schemes. You have a lot of things that revolving around the misuse of this technology for people to try to get rich. It's a sort of a bubble. And so I just want to add this disclaimer here to say that I'm not supporting any sort of specific investment strategies. I'm not saying to put in retail money into it at all, but the reality is that a lot of brands and large companies and creators and tons of people are starting to use this, and so we should understand it from a technology standpoint of why it's important and what it does. So what is Web3? To understand sort of where this term came from, we have to look at what Web 1 and Web 2 were. I'm assuming most people kind of understand those things. Web 1 was the static web. It was just basic HTML, CSS, JavaScript, even the beginnings of e-commerce, right? You could buy things. Web 2 is really where we ran into the seamless integration into our lives. It became very personal, right? We became monetized. Our data became monetized, right? Social media became ad-driven. And in terms of those revenues, you kind of have this concept of surveillance capitalism, the idea that data itself became really a currency in the space. It became what makes things really valuable, right? You think about an app like Pokemon Go that's free. Well, why is Pokemon Go free? Because it can deliver you to places and then push notifications to you. It can track where you are. It can track your decisions, right? All these apps are valuable because of what they know about us, right? Because of data. This is also the beginning of, this is where mobile first and apps and sort of this ubiquitous nature of the web happen. So what do people mean when they talk about Web3? This is really the idea of decentralizing those things. How can you be the owner of your own data, of your own digital items, of your own experiences? And so this is where user first monetization comes in, right? How can you monetize for yourself without a bunch of middlemen or big tech being the ones who monetize off of you instead, right? How can we reverse the flow of ownership? And so this is where, you also have a lot of blurring of the lines with VR and AR, AI, blurring those lines between real and digital, and interoperability too, making sure that everything's kind of talking to each other. You could even throw things like Internet of Things in there, but really what Web3 comes down to is who owns it, right? Who owns the algorithms that sort of run our lives, who owns the data itself that runs our lives, who's signing off on the use of that data to make money. And this is where you see the idea that as participants in the system, as users of the system, as creators within the system, you are the ones profiting as opposed to large tech companies profiting off you existing in that ecosystem. And so that's where things like blockchain come in, right? Because whenever you have distributed ledgers, you have peer-to-peer, you sort of start talking about those distributed systems where you don't necessarily need as many middlemen. You don't necessarily need the larger institutions sitting in the middle to profit off of that experience. Everybody who participates can profit off the experience. There's also kind of a joke in here, Web 5. Jack Dorsey, the former CEO of Twitter, made up this term. The idea was Web 2 plus Web 3 equals Web 5. And really, this is where he talks about identity management. And one of our first examples is going to kind of show why the idea of identity management in Web 3 is important, and how it sort of solves the fundamental issues of username and password and some of these old paradigms that are a bit broken. But the term Web 5, as Jack Dorsey came up with it, was a bit silly. So it's kind of a meme at this point, because Web 3 kind of tackles that on its own. Oops. All right. This is only, I'm going to talk about a specific technology here, a specific blockchain, not because, again, going back to the disclaimer, not because I'm telling you that Ethereum is going to solve the world, that Ethereum is where you should put any money. Ethereum is just a very developer-friendly blockchain solution to kind of give these examples. It's an open source blockchain network. It's where it became distinguished from earlier networks, and this is where I particularly got interested in blockchain way earlier on, is it enables the development of smart contracts, the chain. Thousands of decentralized apps are currently running on Ethereum. And so sometimes I like to give the example that something like Bitcoin might be a specific app. Bitcoin solves essentially one problem in its first layer of, the idea of storage of wealth. Whereas Ethereum is more akin to like the app store or the development platform itself. Because what it does is it allows you to actually deploy code itself to the chain. And I'll show what that looks like here. Sorry, forget. I have a lot of tabs open, and the Zoom thing is in the way. But here, so this is, and I know that there's probably a lot in this page if you haven't kind of been exposed to it before. The idea is this is a website called Etherscan, and what it does is it looks at a specific address on the Ethereum blockchain. And so it's essentially just a window into what's deployed at specific places on a chain. And in this case, this is actually a contract. This is a smart contract. Sometimes an address is just somebody's wallet. So if you look at like somebody's wallet, you could see what they have in that wallet. In this case, at this address, we have code. It's a smart contract, and it tells us who deployed this code. And in this case, this is just an NFT project that has some fun ASCII art in the contract. But this is just an example of the fact that this is an entire smart contract that's been deployed to that address on chain. So when I talk about smart contracts, this is kind of what it looks like. It's written in a language called Solidity, and Solidity is very similar to other recognizable languages. It has a lot of things that people recognize from JavaScript or Java or anything like that. So I hope that's just, I'm going to talk more about that, but that gives you kind of a bit of a view into what it looks like. Okay, so that's what I'm talking about when I talk about a smart contract. And Ethereum also supports different token types. So not only can you have smart contracts, but yeah, you also have this idea of different token types that might belong to different contracts. Those involve things like utility tokens, commodity tokens, security tokens, asset tokens, etc. These are represented by a wide range of standards called ERCs. Okay, so for example, NFTs are typically represented by an ERC 721 or an ERC 1155. And so if I were to show you what that looks like, and these aren't incredibly, I'm not going to go deep into these subjects, but I just want to give enough kind of context. So when you look at somebody's Ethereum address on chain, you can see different ERC20 token types. These tend to be other apps that have been built on top of the Ethereum blockchain. You can see ERC 721 token types. These are different types of NFTs, and ERC 1155 are also different types of NFTs. So when you look at a specific NFT, again, you're taken to, this is a token called Goop Dudes, and it's got a contract that belongs to it. And then we're right back sort of where we were in terms of being able to see the code for a specific project. Okay. And if you have any specific questions around that, don't hesitate to ask. But the deeper parts of this are not super important to our presentation today. But I wanted to give some context in terms of what that ecosystem might look like, where things are built, but they're deployed to the chain. And that's why this is a really great example for this, because what we are going to look at. So the brief history of Ethereum, dev started 2014, launched 2015, had a initial coin offering boom in 2017. This is where a lot of projects were initially built on it. They formed the Enterprise Ethereum Alliance in 2017. This has huge brand, like this is where you have a lot of big brands and things that have joined to start exploring the idea of different decentralized projects that they can do. It became the second largest crypto behind Bitcoin in 2018. You had the NFT boom, 2018 to 2021. A lot of this was speculative, right? You had a lot of like independent artists and things too, but the reality is that you had very large projects that were explicitly designed as generative projects to make people a lot of money, right? And this is where we've had a lot of societal critique of this technology, right? Because when it's used for things that people clearly don't see the value in, right? When you see people just using it to get rich, there's great critique there around, how do we stop that? How do we regulate this properly, right? What's really cool about Ethereum, though, is that in 2022, they were able to completely swap out essentially the entire network with a new, what's known as consensus mechanism. So proof of work is the same thing that Bitcoin's built on. The idea is that the entire network has to verify each transaction. The entire network sort of competes to solve the problem first of creating a new block, right? But the new consensus mechanism is proof of stake, and that's reduced their energy consumption. The most important part of this is it's reduced the energy usage of the network by 99%, which is significant. So instead of the entire network competing to solve a problem, one miner is selected to solve the problem each time. So smart contracts, Ethereum is a dev network, right? So as I talked about, Ethereum provides a network to deploy deterministic public community-owned code to, right? It's this idea of not only is the code open source, not only can you build the code on other code, right? But it's owned by everybody in the network. It's deployed by a specific deployer, but it's visible to the network. It's now deployed to the network, right? So it becomes part of that decentralized network. The code often builds on existing standards, such as how NFT contracts typically extend ERC 721 variants. So in the example of the Loser Club contract that I showed, it's an extension of ERC 721A. And so this is where you see a lot of like standards being useful, right? Because if the networks establish standards for certain token types, and then something extends it to add its own functionality to it, that becomes really valuable in terms of the open source nature of it. The other thing I want to mention before we get closer to some of the examples is that there's mainnet and there's testnets. So at the end of the day, obviously Ethereum itself as a token is pretty valuable. It would be very costly if you did all of your development on mainnet because you'd be using real Ethereum. You'd also be deploying everything to mainnet, right? So this is the difference between production and dev. So in production, you're dealing with real Ethereum on the Ethereum mainnet. In testnet, you're dealing in development, you're dealing with whatever Ethereum testnet you want to use. It's essentially a copy of the Ethereum mainnet, but it's testnet. It's not real money. It's not real anything. And so the dev process for Solidity essentially looks like this. You develop the smart contracts locally using some tools here called Truffle and Ganache. You deploy those to Ethereum testnet, which is public on that testnet, but it's not used by mainnet. And then you develop your app using the contract address for your testnet smart contract. And when that is in a good state, let's say you have all your testing set up, you've tested all of the different things in testnet, then you are ready to deploy to mainnet, and that's when it becomes live on mainnet for people to use your decentralized app. This is all precursor. This is essentially the back-end part of interacting with the blockchain. The smart contract is that back-end part that you're interacting with when your front end using JavaScript that we're going to go over interacts with it. So this is where we get into the stack itself. And this is where we're going to focus on the front end side. And this is where we start seeing how JavaScript plays into this. So you have your decentralized app, and it might include libraries like Web3.js or Ethers, Web3 modal. These are some examples that you'll see. And Ethereum providers. Providers essentially are the layer that interacts beneath with the Ethereum blockchain. So you have providers, or in the case of your development process, Ganache, Test RPC, and then you have your providers that interact with your blockchain layer, mainnet, testnet, or Ganache. using JSON RPC. So next you have your Web3 provider itself, which I just referenced there. They're kind of abstracted, standardized interfaces for the Ethereum blockchain. You can sort of think of them as the API layer that the JSON RPC interacts with. And they're often accessed via wallets, like the MetaMask browser extension or app. So I'll show you what that looks like when we get there. And Infura is a provider that's probably the most common. And so when a user connects their MetaMask wallet to a decentralized app, they're connecting to Infura's endpoints. And then Infura itself is that standardized layer that will then interact with the blockchain beneath it. There are more decentralized or dedicated ways of having your own provider. If you're buying a dedicated node for yourself that has an API layer, things like that. Or if you're running your own node, which is pretty extensive to do, but if you're doing that, then you're obviously able to do things more custom for yourself. And then, of course, in the bottom layer, you have the Ethereum blockchain itself. And so you're accessing addresses, you're calling smart contract read or write functions from the contract address, etc. So this is a diagram that kind of shows you have your front-end app. This is where we're going to focus the most. Uses JSON RPC. You essentially have a JSON file that describes all of your contract specific functions, read or write. You are interacting with an API in the provider, and this is where certain Web3 libraries come in handy because they're essentially they're even adding that app layer to it to interact with it. And MetaMask itself as an app is also doing a lot of work for you as well. And then underneath that, is your blockchain layer that everything is sort of communicating with. So I want to do some demo here, and then we can dig into the code. So the first thing I want to talk about is this idea of signing in with Ethereum, or you can kind of swap Ethereum out for any smart contract ready blockchain solution. And so one of the interesting things to me functionally about Web3 is the ability to sort of solve problems that we've had trouble solving for a long time. One of those is username and password, user authentication. The reality is that paradigm is pretty broken. Passwords are not actually incredibly secure. We've had add a lot of band-aids on top, right? You have reset flows and one-time codes, security questions, two-factor auth, multi-factor auth, biometrics, FIDO2. What if we could fix the underlying problem of letting blockchain do the authentication? That's kind of a bigger deal. So going to go over to this app here. This is a pretty cool project that I worked on. This is not a shill for this project. It's not active anymore. But I think it's a great example of how everything can be connected. This project was originally founded to support comic book artists who wanted to enter Web3. So the idea is that they could produce their original artwork, their original comics, and they could have like a direct relationship with their audiences who enjoy their work and things like that. And on the code side, we're going to dig into how that all connects. So let's give a demo first. And so we have this button here called Connect Wallet. You can think of this as like a sign-in button, and you'll see what I mean. So Connect Wallet. And so in Brave, the Brave has a wallet built in. So this would be MetaMask in Chrome, and I can show you what that looks like as well. So in Chrome, this is what MetaMask looks like. You'll recognize that Fox logo. But the makeup of a wallet is that it has, and we're on testnet here. So you have Ethereum mainnet. We care about a testnet because we're in development right now. And it essentially shows you what do you have in your wallet, and it shows you activity of that wallet. And this is completely decentralized. This is not stored centrally. It's on my own computer. my keys for this wallet are only known to me. And so you want to be careful with things like this. This is open to any sort of like social engineering hacking techniques, but the technology itself is very secure, right? So if somebody convinces you to click on a link and connect your wallet, that's a problem. But there's no other way to kind of hack into this because you are dealing with decentralized technology. And so this is the example of MetaMask, and this is the example of the Brave one. And so if I go ahead and connect here, connect to Brave Wallet, view the addresses. So it even tells me what it's asking to do. It's saying, how can I view addresses of your permitted accounts? And I say, that's totally fine. I'm logging into this app with my wallet, and now I've connected. So what happened here? If we look at the code, this is the next application. I'm running it here, just npm run start on the next application. And so it's pretty standard React stuff. And what we want to pay attention to here is Web3 modal. And because I've already gone through the modal and I've selected Brave, you didn't see the modal pop up. It remembers your account. But I'm using context here. And that context is coming from wallet connection context. And so I have the wallet connect context provider, and open connection is what happens when I click on that button. And so we have this function called onConnect. And so what happens is it looks for our Web3 modal, and then we need an instance. So we either have one already or we need to create one. And so Web3 modal connects. And then I set the instance. This is going back to our state that we eventually give to the provider for the context. And so Ether's provider's Web3 provider, the instance of the Web3, and then I get a signer. Okay, so what is the provider? We talked about that, right? The provider is that API layer that is giving that standardized way of interacting with the chain. And the signer is me. So the signer is that I've now approved it, and now I'm the signer. So now I've gotten the provider and I've gotten the signer. And so now I've been able to connect my wallet to this app. And this app now has access to me as a signer. And so what this has done is it's allowed me in a decentralized way to log into the app in a verified way that's only me. And I've signed to do that. So I become the signer. And so when we look down here at our provider, current ETH account, that's my address now. And open connection, onConnect, that's what happens when I click on the button, and I can show you where that pops up. So I have a button here. That's my wallet connect button. Open connection comes from my wallet context. And so it's, I'm becoming the signer that's now there. I've given it the provider. I've given it the connect function that creates these. And I have my current ETH account. And so this is a great example of now that I am connected, you see my address here. And that address has come from this address on chain. So you see that it's 0x1074, 0x1074. And so what this means is that I now have a direct connection between my wallet and my app that will allow me to do things. So one great thing I could do is I could possibly look at if I have any of these existing NFTs on this wallet. I do not. So in my gallery, nothing's showing up, but the gallery is taking from that address and it's looking for things. I can go over here and I can look at a comic and I can try to mint that comic. So here it shows me how many have availability have been minted. It shows me a price, and I can click on mint now. And so what happens is it essentially takes a look at, it uses a mint function from the contract, and we'll go over this in the next part of the demo, but it is interacting with my wallet in a way that calls a contract function and allows me to interact with the app to make decisions, and then do something on chain using my real wallet and the contract that's also on chain that has the functions to do that. Okay, so before I go on to the next demo, which is going to dig into the relationship of the NFT part itself, does anybody have any questions around the sign-in or the login part? Kind of that idea of connecting your wallet.
Maybe one step back. The two RPCs that you listed, could I think of them as middleware before the API?
So the RPC options. So
Yeah.
JSON RPC, yes. So I should actually show that, what that looks like.
Oh yeah, thanks.
So when I look at like a specific project, maybe this one, I have a JSON file here that gives me the JSON model of the contract on chain. And so in that JSON file, let me look down here at utils, JSON. This is an ABI that gives me all of the things that are supported by that contract in a JSON format. And this is how we interact between the app and the provider. That JSON RPC layer is handled by recognition of what's available to us here. And so I'm going to show that a bit more in the specific example of the NFT demo, but this part is actually not super relevant to the login demo. This is more relevant to if you're interacting with the contract, whereas simply logging in is more of the app interacting with your wallet. Does that difference make sense? So if I'm just signing in with a wallet, I'm not doing any RPC calls with a contract yet. That's just app to wallet. And you can actually see what that looks like. I do window.ethereum. Window.ethereum describes my connection to that wallet. So there's a lot, essentially everything that's being handled through the Web3 libraries is interacting with what's available to me on window.ethereum. And that's where like you can look up which Ethereum accounts on your wallet are connected to it, those like what those addresses are. If you ask for permission for it, you can see like what the balance of that address is, etc. Any other questions on that connection of just the app to the wallet, the sort of that login portion?
I just had more of a statement. It took me a bit to figure out that in Brave, you can go into the settings of the wallet and turn off the integrated wallet. So you could use MetaMask and Brave, or if you install a Coinbase wallet, you gotta like turn it off. So they can interfere with each other pretty easily in your browsers. That's all.
Yeah, that's a good point. A lot of people will add MetaMask to Brave, and because they're both interacting with the window.ethereum objects, it's kind of a mess. And there's sometimes if you're developing an app around that, you actually want to figure out a way to try to recognize it. But it's not super simple because they're both modifying the same object on window. The other thing I'll note too, from your wallet, you have the ability to disconnect. So you can go back. This is good to do, especially if you've interacted with any sort of app that you're done with, and you don't want that app. Let's say that app for some reason ends up getting hacked. Let's say you've connected to a certain bridge or something. There've been a lot of bridge hacks. When you're done doing something, you want to go in and you want to disconnect, because now, even if you revisit that page, you're no longer tied to that app that could potentially, try to do something nefarious on your wallet. Okay, so let's dig into more of that that contract side of things. So once you're logged in, the process of calling the contract functions it uses, in terms of the JavaScript paradigms, you'll recognize them right away. You're essentially you're dealing with promises. Because let's say I want to mint a certain NFT, you're going through a transaction process of establishing a hash. So that hash is a transaction on the chain. It's essentially, it looks like an address hash or a contract hash. It's just a hash of a transaction. You get receipt of that transaction and then confirmation that it's completed. So that transaction now exists. You're getting a receipt of it existing, but it's not confirmed yet. And that confirmation process is where the network itself is verifying your transaction. And then when it's completed, you get confirmation. And so looking back at that mint process, if I connect my wallet, and I go to mint, let's say I want to mint another frame. I don't know this one. So I can, if I click confirm here, then that would mint that NFT to my wallet. What we want to know is what process happened here that interacted with a contract function that opened up my wallet, right? So in this situation, we want to look at a mint functionality. And so rather than redeem, let's look at mints. All right. This is for one of the other projects in here, but you'll kind of see the logic here. So NFT contract, where's that coming from? So NFT contract is that contract that from the ABI. And so I have that NFT here. I'm calling it NFT, but it's essentially that ABI that's coming in. It describes all the functionality of the contract. When I load the contract, this is something that I do using an effect. And I make sure there's a signer and provider, right? That goes back to the fact that a wallet's connected. I make sure that I have a contract address. This contract address comes in from environment variables. This is because we have a different one on testnet versus mainnet. So just to show you what that looks like, I have a environment local. These are my testnet contract addresses. In production, I have mainnet contract addresses. So that's an important thing to point out. So if I use signer, I have signer, and I make sure Ethereum's on the window. If Ethereum's not, then I know that I didn't actually have signer and provider, even if maybe they're in the context. These are just extra safety things. I use the Ethereum provider when I get signer, if it didn't exist. So ethers.contract, I give the contract address, I give the NFT ABI. This is where I get access to all of the contract functions. And then I give my signer. I also get some other data. So I see how many llamas are left. This was a llama project from an artist. So one of the important things when you're maybe minting an NFT, you might want to get some other data from that contract to make sure you can, or get some other data just for your app experience. So I want to know, in this case, I want to know how many of them are left. I want to make sure that I get the total supply. So that way I can have some math around how many are left of the total supply. And these are functions that are on the ABI. So they're available to me because I have that ABI. And I've created this ethers.contract object here. And then I can use signer, I can get address, and this is where I get how many I might have, the signer might have a balance of, just so that I know how many they already have. Let's say you have a project, you want to limit how many people want to mint. So these are just, these are very specific to certain NFT projects, but the idea is that I'm able to grab data from the contract that I can then use for the experience, the Web3 experience I'm creating. I get other data price, I get the mint period, I get batch size, max per user, right? So then I'm also setting the contract here for state. So when I then go to mint, I know that my contract's there now. So what I do, sometimes you might have to be on a pre-sale list. So in this case, I'm checking if you're pre-sale, and I'm deciding which mint function you're allowed to use as a result of that. And this is some other like queue stuff for like showing errors, things like that. And then I give it some params. So in the case of a pre-mint, I have to provide a proof that they're in the pre-mint. Otherwise, I'm just giving value of a total price. So this is me passing the price to the wallet. And so mint function, remember this is coming from the contract. So let's say NFT contract.mint. This is a function that's on the contract. And when I go to mint, I then get my transaction. So I grab the hash and I say they're hurting your llamas. I log the hash just in the console. I'm waiting. Then I get receipts. So upon receipt, I get a transaction receipt. And if it's good, if the status is 1, you've successfully minted. And that's essentially the confirmation, right? So I've confirmed that the status was good, that the transaction went through. I throw a confetti party. So that's essentially the mint process. And so you notice when it gets down to it, none of this is like, these are all relatively common JavaScript paradigms. You're just dealing with promises, but the difference here is that those promises are interacting through your provider or through your wallet, through the provider, and waiting for the blockchain to give you information back. And you're calling functions to do that off of your contract itself that's on chain. And so to show you again, what that might looks like. So this is that ERC 721, that's an NFT. But in here, you see that these are the functions that are available to us in the contract. And so you might have, there's a better way to look at that. You can look at the right contract. And so you might, they have something called mint public. So like in their case, the mint function was called mint public. And so mint public takes the amount, the cost, and the number of them. And so that's behind the scenes on chain, on this address, on this contract address, through your ABI to know what the structure is. Your JavaScript is interacting through your wallet to verify your funds, all that. And then it's carrying out this transaction, calling these contract functions. So this is sort of the power of Web3, is that, you can kind of start distributing your functionality to community or network owned things. And that's an example of how JavaScript sort of connects to those things behind the scenes. Any questions on that part? I know that it's at the intersection of a lot of subjects, and the JavaScript is kind of one of the simpler parts of the conversation, but JavaScript, of course, is at the root of how people through apps interact with those things. So any Eric, you have your hand up?
Yeah, so let me see if I have this right. So you can define all those functions and Solidity in the contract, and they're virtually endpoints, which then the JavaScript in your application, or in your case, the TypeScript, can touch those endpoints just directly from the contract object. Is that right?
Right. As long as you have a provider and a signer. And so if you have a provider that's giving you that API to interact with the chain, whether it's your own hosted one or if you're going through something like Infura, and you as a signer have connected, right? Because you have to be, the entire point of blockchain is that it's verified, right? You have to sign transactions. So your interaction with those is dependent on you being a signer to be able to do that, to make that decision and sign those transactions. All right, so what's the future of that look like? Token gated exclusive content or membership. You can have like members only content, AR, VR, multimedia experiences, creator subscriber relationships, right? Deals, promos, invites to, real events, early access to things. You could say let's say I'm a musician, you own one of my NFTs. Maybe I gave you one. You have an NFT that proved you were at one of my earlier shows. Now, because of that, you get upgraded to VIP access to my concert. You get exclusive content. You can have tokenized event ticketing. So concerts, conferences, sporting events. Your ticket can essentially become a token that you hold that's scanned at the door, right? They just scan your QR code for your wallet. It verifies that the token's there, et cetera. Cross-app and interoperable ownership. This is the other huge part of Web3. Owning digital assets across games, right? So if the digital assets that multiple games or VR experiences are using are on my wallet as opposed to stored in centralized places for those games, I might be able to carry those across, right? I can carry my outfits, I can carry all those things. I can own those things in my wallet and they become cross-app. And then data ownership and signature dependent access to data. So let's say that all of my data for social media platforms or for my professional networks, let's say my LinkedIn data, let's say that data itself is owned on chain or in my wallet, and I have to sign every time somebody accesses it. They have to ask my permission to use it, and I have to sign and say that's okay if they use it. This sort of redistributes ownership of our own data. Let's say I'm looking for a job and the companies are reaching out to me to say, let's say they're casting a broad net to search for candidates. Let's say I can verify that some points of information that I qualify for the position. And then as the relationship progresses, I can give a little more information. I can sign off on that. As I progress through that relationship, and you don't have something like LinkedIn sitting in the middle. You don't have all of my data available right away. Another example of this is like, let's say you want to rent a place and you don't necessarily know the landlord. You may not trust the landlord. You can essentially use zero knowledge proofs using blockchain in your wallets to verify you qualify based on their parameters without giving them all of your personal information. You can just, using blockchain, verify you qualify for moving in, and it starts reducing those vulnerable touch points. User authentication identification, we talked about this, being able to log in, manage your accounts, have direct connections to your wallet, streamline payment, right? So let's say you've already logged in, well, your wallet's already connected, but it's done so in a really secure way. You're not having to give your payment details, numbers, bank accounts. You're not having to keep those relationships open, but it allows a secure way to do that.
Fucking loser.
And then you could have, identification, work IDs, government issued IDs, real world asset deeds and records. You can start tokenizing these things and keeping them on chain, and you own them. You don't have to worry about them being stored in some sort of, filing cabinet or something like that, right? It starts reducing the areas where things become vulnerable. And then this is the other part of it: shared utilities, decentralized autonomous organizations, P2P, gig economy. One great example is Ethereum name service. So you can buy domains through a shared utility called ENS. And so I own bestfoodalex.eth. I'm not relying on some big domain name provider that I have to pay every 5 years. Instead, it's actually completely decentralized. All the governance is decided by all the participants of the system who rely on it. It starts becoming a bit egalitarian there. For certain public-ish utilities that everybody shares, there's not necessarily a reason you need a big company conglomerate in the middle to profit off of that interaction, especially when it's a relatively simple thing that we're all sharing. Aggregate data APIs. There's oracles like Chainlink that make data available using their system. And so you can have reliable data aggregates for those APIs, again, without relying on big tech companies. There's other things like VPNs, file storage, and cloud computing that are being worked on as distributed systems using this technology. We did it. So I know that's a lot. There's a lot in there. It's, there's a lot of misconceptions about the space. There's a lot of open questions. There's a lot of things that need to be improved on. This is emerging technology. It's not perfect. There's a lot of misuses, as I mentioned before. But as somebody who originally got into this because I fell in love with the technology itself, and it couldn't, obviously a lot of those things grew into these other things. At the end of the day, again, it's clearly being adopted in a lot of ways. A lot of, it's beginning to kind of become more standardized in terms of how a lot of institutions and companies are using it. And so it'll be interesting to see where it goes. And that is it.
Heck yes.
Awesome.
Oh my gosh. Thank you, Alex.
Of course.
That's amazing. All right. So I know we're running a little bit over time. So thank you guys. And also, they're all really valuable presentations. So let's move to Jesus. So Jesus is a full stack developer from the Dominican Republic who is joining us tonight. He's passionate about programming in general, web development, and Vue.js, which is actually what he's talking about tonight. He's worked for over 5 years with the Vue ecosystem in several projects, including startups, and currently is a software engineer at EPAM. And I love this. He loves to learn new things, share knowledge, and create apps, write poetry. And when he's not doing that, singing to Bob Marley and running. So as a fellow runner, I love it. Jesus, you are co-host. You can share your screen. Take it away whenever you're ready.
Okay, thank you. Let's see. Let me know when you can see my screen.
Heck yes, we can see it.
Okay, nice. Well, this is my presentation. Is basically what you heard here. And I also like some kind of blues, the old blues. And I heard that Chicago is very famous for that kind of music. I have heard some songs that are very interesting and mention Chicago. So in addition to that, you can find some of my thoughts on Twitter and some of my experiments on exploration in Dev2 and GitHub. One of these exploration is precisely the topic that we are going to talk today, that is headless component. The content of the talk is like short. is what are headless components, some of his characteristic pros and cons. We're gonna build a headless component using the Vue composition API and Tailwind CSS. And at the end, we are going to share some resources, libraries that can help us to apply that concept in our projects. So, but first, let's start with the problem. And it's what we when we are building our application, we are kind of reusing the same logic, the same behavior, but and that is why we separate that chunk of logic in simple components that we can manage and we can reuse. But in the step of doing that, we are sacrificing some modularity, like flexibility with the UI. And installing NPM components, we are installing as well an opinionated style, an opinionated user interface. And when we are dealing with simple components like inputs, cards, and avatars, it is easier to work with that. But when we are dealing with complex components like step wizard, file loaders, combo bots, it can be really complicated. And most of the case, the UI library don't come with UI flexibility in mind. Things like Element Plus, to mention something, they don't have that. Apart from the theme specification, we can change the shape, the shadow of the element very easy. And here is well, headless component comes to the rescue. So what are headless components? Headless components are like normal components. We still have our structure, we still have our logic and behavior, but we don't have an opinion on a style. We don't shift it. So we instead let the user, the developer, to decide how they want their component to look like. And we instead expose values and expose controls to serve as a support to help the developer make those decisions. So, and this first characteristic is on the style. For example, in that component, we are exposing, this is a combo box, and we are exposing a state that is selected. And this state is helping us to decide to show this little check when we select an item and to control the background that we want when we hover this item. So another characteristic of headless components is accessibility. Accessibility is no longer a second thought. Our application has to be reachable for screen readers, have to be, we can navigate through the keyboard only and provide a right to left to build an application more inclusive in order to be according to today's work and today's needs. Design system. This is a main problem because when you are building applications that don't share the same design system and you are using component library, you just have to go to inspect element, find the class, and try to fight with the specific words of CSS to try to override those styles. And this is not as easy as it may sound. So to avoid that, with headless component, you can change, for example, with the big Joby theme that is red, we are just using the same component. And we, instead of the green, we just define red, and it is easier. We don't have to fight, we don't have to override anything because it's a fresh style that we are setting up. We create an abstraction for components that behave the same way. We are going to check that use case later. And as I said, not need to override styles, and it can be integrated with multiple style approaches. I mean, CSS, plain CSS, Sass, or Tailwind CSS, that is the most popular styling option right now. So we are going to get our hands dirty and let's review how to build a Headless component with Vue.js and the composition API. To do that, I checked ahead of time a live application that is called Tally. It's a form builder and have some interesting components like this one that is a single choice array component, very simple, but complex enough to let us work and scale. If the time allows us, let's build at least 2 of these components with the headless approach. So the first one is array component. Here are the requirements. The user can specify the count of how many stars should be displayed, should expose the selected state, and should expose the cover state as well. As I say, Tailwind CSS for styling and Vue 3. So let's see some code. Here in the first, we are going to define our props, and I'm going to translate, try to translate to a different framework like React.js, some of the concepts, in order to let the audience to be familiar with what is happening right here. So model value and count are like props. Model value is a special kind of prop here in Vue because it's double binding. The value can be updated from the parent component and also can be updated from the child component by emitting an event. So next we define last hover item. In that variable, we are going to save our the last item that we set our mouse over, a range. Here with the range is something, this is some trick. We are generating an array for the count. In that case, we are gonna pass 5. So we are generating an array of 5 items, and the computer indicate that every time that count changes, it will be recalculated and update the value of range. Next, we are defining isCover, an isCover function that allows us to know when an item number is covered. Cover is greater or equal than the current value, or greater or equal than the last hover item. Is selected to indicate when the value is selected, if the same is the item number, and set hover to set the last hover item. Next, we are going to define our template. A slot here in JavaScript and Vue.js is similar to child components in the child prop in React. And we are basically saying whatever thing I pass you as a child, rendered X time. So in index, we are going for a loop of range, in this case 5 times. We are going to render 5 times whatever thing we pass as a child of the very rate. And here we are taking our function that we just defined to set this, to share the state values for the child component, the item number that is selected and the isCover. We share also the set hover function. So here is a component in action. So we just pass a 5. We want to render 5 stars. We are accessing to the selected cover item number and set hover that are our state values and functions. And here we are defining the logic. Every time we click the button, we set the rating to the current item number, like here. If we press 2, it's 2. If we press 1, it's 1 star. The set hover, every time we we put the mouse over and start, it's covered, it's hovered. So check that if I put my mouse in the fourth start, the 1, 2, and 3 is covered because we define that, we are setting that. And last but not least, we are deciding that when the item is selected or is covered, we want the text to be yellow. And that's why it's changing the UI. And otherwise, the test will be gray. So notice that this can be improved because we are just defining a logic that could be abstracted in the element in order to make the job easier for the developer. So we could refactor this by, let's see. Okay. We can extract this by building a birth rate button component that is working as a child. It's basically the same functionality of the list component of HTML, like Jewell and Lee, that they have meaning only when they work together. So we are building a birth rate button component, and we extract that logic of setting the rating when it's selected, and we are the hover state as well, and it just works like before. Here is what we've done in order to let that to refactor the component. We went to our principal component, main component, and import the provide. The provide works like the context API of React. We are providing a property, a value to the child element to make accessible whatever function, item, variable to a child component. In that case, we are defining a set selected. Here we're going to use the update model value, that is the double binding that I talked earlier, the V model. And here we are exposing, we are providing the controls, and the control is equal to set hover and set selected. In the verb button component, we are importing the inject. The inject is the function that let us use the context of the parent component. And here we're defining another prop, the item number. And here we using the set selected function and set hover function in order to let the child component to manage the behavior of the set selected and the set hovered. It's just work like that. So do you remember that earlier I mentioned that with headless component, we can extract logic and reuse for components that behave the same way? Well, that was a little trick, a little hint, because we are not going to build another component. We are just reusing this logic because the scale component is the same. It's just behave the same way. And we just need to change the UI to work, to make them look like we like. So here, instead of 5, we are passing 10 to render 10 times a button. And here we are using selected an item. We no longer need hovered covered because we are not changing the UI based on that state. And here we are setting our style, like when it's selected, we want another style that is basically, that is basically, well, it's not dynamic, but basically we are changing this action, the colors, when we set the selected item to this number. Let's see. And the other component, we can just reuse the same component, the same birth rate button to build another time, because the single selection, if you notice, is the same functionality. We are just rendering a list of options and setting an item number to the value and changing the UI based on if the component or number is selected or not. So we can easily rebuild that. But we don't need to build our own headless component each time we need them. In the community, we have some options like Headless UI. That is a very good library. It's a very good library. Even though they have a limited number of components, they are like components that you are always using, like combo bots, list bots, menu dropdowns, disclosure, that is like collapsible, and dialog. And Radix is a more, it has more components. It has a very well designed and have put a good effort on accessibility. They provide a good navigation, a good keyboard-only navigation to the components. They as well provide good ARIA text for screen readers, and they are well done, very well done. So wrapping up, headless component provide us a way to reuse logic, but with the flexibility of letting us customize our UI. So in order that we can use those components across different projects that have a very different design system. And the only downside I have seen working with headless components are they tend to be verbose, and it's not cons, it's like a trade-off, because this is not only, it's not cons, but is what allows us to build a flexible component. So it's verbose, and in order to deal with that, we can just grab our component, our configuration, like a array component. We set the configuration, set how we want how we want it to look like. We just wrapping up in a rate component, and in the scale use case, we just wrap that up with the configuration that we want and build a component that just serve for that function. In that case, we can share that specific logic across the application without having to define again all that configuration, and it's no longer a verbose approach. So it's like a trade-off. So this is the most important. I hope that this talk serve you to investigate more about headless component, about Vue, and why not using in your next project. If you have any question, I'm open to answer it. Thank you.
Yeah, does anybody have any questions for Jesus? That was awesome. Thank you so much. And we do have one final speaker for the night. So, again, you guys feel free, like if you have a comment or a question that comes up for either Alex or Jesus, please always feel free to throw that in the chat, and we'll make sure that gets answered. But all right, we've got one final speaker, Kevin. So Kevin is I'm going to share my screen super quick. Perfect. Thank you. Awesome. So Kevin's a web developer from the high desert of Reno, Nevada. He delivers premium code at TJ Maxx prices and will never write a homespun router for a single page app ever again. So welcome, Kevin, and he is going to talk about building for the metaverse with VR in React. And I will give you the floor, Kevin.
Okay, thank you very much for everybody else that's hanging on here, because this has been a very large amount of information. Fortunately, I don't have like well, I've been attacked. Fortunately, I don't have a whole lot of code to dive through. I have some very practical, ridiculous examples. I have some really wonky, terrible UI to share with you all. And what I'm curious about, and feel free to just break all rules of Zoom meetings and go ahead and unmute yourselves and shout, or use the chat. If you have used Three.js, or you've been using React 3 or any of the Three.js wrappers for React.
Not yet.
All right, yeah, one. And anybody that has, what have you used it for? Well, I don't think the others come through. Either way, Three.js is it's the most established 3D rendering library for JavaScript, and it's kind of starting to feel a little bit crusty. And there's been some alternatives as we move forward and we start imagining how we're going to build VR and AR experiences that can be deployed through the web and can be delivered to people through browsers. So graphics in general is experiencing some very large shifts towards using GPU better and all these things. And I'm sure anybody could find a way to deliver a product in a more engaging or interesting or clear way by using a fully involved 3D environment. Now, VR headsets are generally not used for more than an hour at a time. Some people do it some more. They're still working into that space. But like Web3, it's a good thing to start learning now and building your foundations so that you're ready if you find yourself in an opportunity to deliver a very involved VR or AR experience. So right now, I'm going to start with a pretty straightforward application that uses some basic 3D graphics rendering. And I want, if any of you have experienced 3D graphics before and have worked in even 2D graphics, to try to think how this would be constructed, what it would look like, what the code would look like, and how it would be structured, and how you would control the logic. So let's go ahead and start. All right. So, oh, look at that. I've deployed something. Well, let me pop over here for a second. I was trying to get this to work on GitHub pages, and I did some nefarious things to my Vite config here. I'll fix that up. There we go.
Do I need to put my VR headset on?
No. I would love that. I would love if we were actually working through that. Yeah, and I was trying to put together a GitHub pages presentation that would involve it if you had that opportunity, but instead you're going to watch this through Zoom. Boom. There you go. That is the excitement that you get with 3D graphics. That thing just flew at you from the Z-axis, and I'm hoping it knocked some things off of your desk. So the next thing we can see is we have rotation. We can see fully animated things happening. And like I mentioned before, you might be thinking about what sort of code you'd be using to render something like this. This is a lot of triangles. It's fully text enabled. So how would those triangles get in there? And then what's this over here? The light switch turns on and we have some state controlled. And now we're going to the next thing. So here's the basic example that the particular library that I'm championing here uses. It's very simple. We click, we have hover state, we have toggling click state. So we have that in place. And finally, let's say we wanted to inject some data in there. I just made some mock data. And here I am now controlling Orbit. And I'm sorry, I'm running on a 2012 MacBook if you're getting a very choppy stream. But what we have here are boxes arranged in a 3D plane that are responding to my presence. Now, if this was using the inputs from, say, VR controllers, or even the fingery ones that allow you to really get detail on every single digit and on every single phalange, you could be using those inputs in this particular library. For now, I'm using a touchpad, and just to emulate through this forum the way that you might be moving your head, or maybe using the controller to zoom in and out of a space. And also, we can see that these names that are attached to each of these objects do have an awareness of where you are in the space. They are rotating in order to lock onto you. And we'll get into that in a second. We'll see what solution the library I'm using gives us in order to achieve these results. So that's it. All right, I'm going to switch over to the actual code space so we can see that. All right, and so here we are. Let's get order away there. And so here we go. Here is the first scene that you saw with the text, the light switch, and the next button. So we have React components that are using refs, even though they're functional components. We have use state being used to control the state. Lots of really familiar things that will jump out at you if you've used React a lot. Right here, we're using a hook that's provided to us by this library. And this library is called React 3 Fiber. React 3 Fiber is supported by a very vigorous community of people, and they have a lot of functionality built into this. And that's why I champion it. And I think this is the best tool if you want to use React for state management, but you don't want to have to worry about actually building wrappers around a graphics library. So they've solved that problem. And what's really nice is, as you see this overview, and I'm going to stop right here at the actual layout, which almost, especially if I get my terminal out of there, we've almost fit that entire scene onto about 25 lines of code. So that entire scene that was shown at the beginning with the light switch, with the text flying in, with the scene, with all the lighting elements that were going on, and subtly it was actually changing the source of light according to where my mouse was. It's all in this bit of JSX here. So does anybody have anything that they'd like me to clarify about what these particular items are? Is there anything that's like particularly pressing that you'd like some detail on? You can jump up through the chat, or please use your microphone if you would like to.
Just real quick to clarify, the components that you're using, are these pre-built, or do they come with the package you're using?
Yeah, so React 3 Fiber has a very curious and kind of novel way of packaging these components. You'll notice that some components have an unusual casing syntax, where they don't use a Pascal case the way almost all React devs have now come to get used to making components. When something is in a camel case like this, it's actually not calling on a React component necessarily. What it's doing is it's actually just using that as an indicator for what type of Three.js object to create. So it actually just takes this label here, and it generates the Three.js object, and then pumps all those props into it, because Three.js uses a very XML-like syntax. It was very much made for kind of a script tag living inside of a HTML page. Is that clear?
Definitely. I wouldn't say I fully understand it, but I'm realizing that it's, I gotta think outside of just straight React component library.
Yeah, this is not usual. This is kind of bizarre, and it actually gives you a really nice little escape hatch, so that you're not thinking in terms of a React component with all of the ideas that you might have ready, but it behaves exactly like you would expect a React component to behave. The props come in, they inform the behavior, and then you get a result in the UI. Now, I've built some components around that. Here, like the light switch, it is just an abstraction, and that's why I'm using Pascal case. It's up here, there's the light switch, but it returns these lowercase tags. And so that's still just returning a Three.js object. And the reason they're doing that is because Three.js is yet another abstraction layer on top of WebGL. So graphics is very complicated, but by doing all of these abstractions and having Three.js with React 3 Fiber controlling things, and then having React itself controlling state, you get something very complicated to get done in a very small amount of code. So it's easy to reason about and think about.
Can I see the impressive text component you created?
Yes, absolutely. And that's where a lot of state, I loaded in a lot of state here to just, well, not a lot, but this is starting with the clicked and click use state, which is in almost every single component you might make that needs some kind of special click behavior. And then here I'm using something that's a little bit more graphics oriented. It's that Z position. This is what creates the zoom effect. So I just start it with the zoom effect way off in the negative direction, which is actually in front of you. And then we use a hook called use frame, which runs every single time that request animation frame runs. Now, request animation frame is a browser API that's very, very important for graphics because it lets you hook into whatever the screen is ready to render at that moment. And so if I haven't yet reached the front of the screen, I just keep on moving that Z position forward. And then, so this is running every single frame. And then also every single frame, I'm checking if I'm clicked, because that allows me to do that rotation effect. And then also I'm able to bundle my React state into the animation frame. This is where it's very, very convenient, and where handling things like this before with vanilla.js or basically any other abstraction was very painful. So I can actually trigger my use state and use the mutator function that's built into it to set an item based on my ref. So I'm actually able to have a ref attached that controls React state. That is kind of ridiculous, actually. It's something that we've moved away from, and they're just keeping it alive by having this pattern, because it's actually a really convenient pattern. See, this ref is attached to that text, and that's the end of it. We have to, for a little summary of how graphics is rendered, you have to attach a material to any object that you make. You make a geometry, and then you have to wrap a material around it in order for it to be visible. That's not super important for this case, but
Is the text CPD from Dry or anything like that? Or
yeah, that's from Dry. That's from basically it doesn't do a whole lot, but it does simplify the process of loading a JSON font into a geometry. So it turns a JSON font into a geometry, and so I'm able to do that all with one line here. Yeah, it's a Dry kind of, everything in Dry tends to work that way, where it reduces stuff that you don't like to think about. All right, so let's move on to the next scene, where we just have those two boxes. And I'm not going to cover this too much because it's just basically the demo that they use. But it's just an even simpler version of using a ref, having hovered and hover state and click state, and just being able to control things in a very React-like way, but with these very curious lowercase React component names. All right, now we can just, if you want to, at the very beginning of this talk, I linked the GitHub account for this, or the GitHub repository. And so you could go in and take a look at that third example. It's a little bit more detailed because it's actually using data. So right here, you can see return the mock data, and we're mapping over it, and we're creating a bunch of components. All right, and this has been a pretty long talk, so I'm going to move forward because I gave a really lofty title for this talk because I was working on some WebAssembly at the time, but that's just, and also the whole metaverse thing is now completely in flux now that like this was just like 3 months ago. So I'm gonna stop it there and just give a little bit more detail for everybody that's interested in React 3 or React 3 Fiber. Does anybody have any other questions concerning the actual code that's running this?
At least one.
Yeah.
So you're talking about components that are sort of defined as objects?
Yeah, you use the new operator in, or the new keyword in Three.js to create these objects on the scene.
Are the props essentially defining initial states then of the objects?
Yes, that's
Okay.
yeah.
So
as
is there a parallel at all with what Redux is we use it for?
In terms, see that I thank you for asking that and kind of bringing that in. That's really good. Yeah. So something that I think we've kind of lost on the trail of React, that as we've been building with it more and more, is that we kind of confuse JSX and some of the things using hooks with React. React is just a state management library that happens to have all of these layout tools and these new paradigms for suspense and things like that now built into it. So with Redux and using the Flux type pattern, you generally are just building on top of the key need of state management. And in this case, I'm just doing straight prop drilling. I'm just putting props directly where they need to be. I'm not worrying about the global state because this app is very contained and very small. But besides Redux, any sort of global state management would achieve the exact same end in this kind of app as just React alone. If you used, I could see Redux being very useful, and maybe some of the faster alternatives to Redux that we have now would be very useful if you were running, say, a full 3D game, and especially if you're managing like network input and output. The Flux pattern is really useful for that, especially like trying to catch fetching and using React query. So I definitely think Redux would inform that kind of thing. But for actually just rendering, there's not that much added value there. Okay, so that's good. That's all for the actual code here. I really invite people to play with this. React through Fiber is extremely easy to toy around with. It's very fun. It doesn't really have a lot of foot guns in it. You do have to wrap your head around this idea of these lowercase names, but once you do, it becomes very natural. And it kind of pulls you back to some of the more foundational elements of JavaScript. All right, so I'm going to share the VR and AR element now. So let me get back on my browser. I'm not going to show code for that because it's so much more than we can really conveniently share through this medium. Let me get the Zoom guy out of here. All right, there we go. So just an example of things that people build with React through Fiber that kind of give you a larger space to think in and operate in. I'm just pulling up a small app that someone's put together. And this is where we start to see how much math can actually happen at one time. If say you were considering a real VR and AR thing, and like I mentioned, this is a 2012 MacBook I'm running on. And you're starting to hit the limits already at this point if you're starting to build for, say, the average processing power that someone has on hand for a browser-like app. So you can do it, though, if you build very carefully and you use your, say, natural optimization. You can do some really nice things. And then once you're ready and you think that your geometry isn't going to break people's experience, you can jump into another library that the React 3 team made called React 3/XR. So React 3/XR is just another layer, another abstraction here to help you get access to all of these web APIs for inputs, primarily for inputs. It doesn't have to worry too much about, say, like orbit controls and moving through a space. But say you were building for a team that wanted to create like an immersive product review system or something like that, or being able to manipulate with your hands, or somebody that wanted to visualize really complicated data, say like at a scientific level, where I think there's going to be a ton of innovation and a lot of people are definitely going to get on board. You would probably get into this, where it might be a really quick off-the-shelf thing, so you could prototype really quickly and just drop another component in. That component will give you access to, say, touch controls or orbit controls that are built through an Oculus controller or something like that. Like right here, you can see this is This is a demo that you can run live as well. It's taking care of that phalange support, which for certain types of manipulation could be right around the corner, definitely starting to become realistic for actual building. Now, I just want to end it with the fact that you're still using JavaScript to do graphics, and you are going to hit a wall. So for those who are interested, getting to that next level, the tool that will definitely fit that last problem there is Wasm. And Wasm is already getting very mature very quickly. It's advanced to achieve one very simple goal, which is to let you run code that is not JavaScript in the browser. Like, it has other goals. Wasm and Wazi definitely are going to enable some very interesting runtime abilities, but the problem they're fixing is that you can take C++ code or Rust code or Go code and put it in the browser. So this is an example I made for a recent talk that's just very straightforward. And it's just this very simple algorithm that moves values around. But this is all running in Go there, and it's just being piped through a little tiny bit of JavaScript that runs the Wasm file. So this is where I really see the high level performance things. Say you get a prototype done using React 3 and React 3 Dry and even React 3 XR. Then if you had really kind of have a great proof of concept, you'll want to jump over to something like Rust or C++ and start really working without all the limitations that you'll have when you're doing GPU intensive operations. So here it is, a little bit of Go, and this is Go actually listening to those event handlers there. It just changed the way this behaves. And I'll post a link to this. And for an example of how much code this takes, I'll just show you really briefly how much Go it takes to create a program like that. And I mean, now we're kind of like out in the woods, but of course, it's good to have this in mind. So this is just 222 lines of Go that's written with very little optimization, not worrying about it, but it still can run a ton of computation far faster than a native JavaScript solution for any kind of graphical application would need. And right here, it's actually directly jumping into the UI, directly jumping into the DOM and manipulating things and then reading values. So you'll probably get there. I hope that everybody gets to get here, because this is when it gets really fun and you can build really amazing things. So I appreciate you all taking the time tonight and absorbing this and just considering this and giving me the opportunity to share this with y'all. If anybody has any other questions, please let me know.